Okay, so the next thing that we're going to be doing is we're going to be trying to describe the pattern and writing the next term and also writing a rule for the sequence. So when you get a sequence of numbers, you've all done this before. You've tried to, you're given a set of numbers and you're trying to find a pattern. So we've done this and we haven't just realized that we are, doing geometric and arithmetic sequences. So a couple different things we want to do here. We first need to describe the pattern. So that's just looking at the pattern and figuring out what the pattern is. So looking at what relationship we see between each term and the one next to it or previously from it. And then once we understand that pattern, we can write a rule for the nth term. So we're going to write a pattern that has n in it, which helps us figure out what our pattern, our rule is, and how to figure out any term in our sequence. So let's look at this first one. Now, what I want you to notice, and after working with all of our rational expressions and our quadratics and polynomials, where we've been taking expressions to higher exponents, you should realize right away that each of your numbers is not a perfect square, it's a perfect cube. So we get 1 cubed, 2 cubed, 3 cubed, and 4 cubed. Now remember, with a pattern with n, we're going to have n increasing from 1, 2, 3, 4 every time. So here, since we see, n cubed would give us 1, 2, 3, 4. So we get, n cubed is definitely going to be part of our pattern. However, we also notice this negative sign in here. So we have to pay attention to that. How do we get this negative in here? So what we want to do, we figure if we have negative n cubed each time, that's going to leave us this negative out here. So as far as describing the pattern, we see that we can write the terms as -1 cubed, -2 cubed, -3 cubed, -4 cubed. Now, obviously the next term would just be -5 cubed, which would be -125. Now, a rule for the nth term, again, since if n is negative each time, we're always going to end with a negative number. So our rule for the nth term is just -n to the third power. So that's how we do it here. We just find your pattern, and then you figure out how you can simplify that pattern into a rule, and then that becomes your pattern. Now, this next one, we need to think about this. Sometimes the patterns are very obvious, sometimes they're not quite so obvious. Now, first, if you look at this, we want to see if we can see your simple patterns, like if they're adding by a common difference, if they're multiplying by the same value, if they've got an exponent. So you can first of all tell this, whereas in our first part they were all cubes, this one doesn't have that. They're not all squares or cubes or anything like that. Now, one thing that jumps out at me is these are all increasing by 0 to 2 is an increase of multiplied by 2, multiplied by 4, or 0 plus 1 is 2, 2 times 3 is 6, 6 times 2 is 12. So you're trying to find this relationship, and it's not quite there. But one thing I do notice is that 0 times 1 is 0, 1 times 2 is 2, 2 times 3 is 6, 3 times 4 is 12. So it looks like if you're multiplying n by the number after it, you get each value. So if n equals 1, 1 times 0 is 0. If n equals 2, 2 times 1 is 2. If n equals 3, 3 times 2 is 6. If n equals 4, 4 times 3 is 12. My guess would be that if n equaled 5, 5 times 4 would equal 20. So we see that we're multiplying each value and the one before it to get everything. So we can look at these. We can write each term as n times the one before it to get our value. So 1 times 0 gives us 0. 2 times 1 equals 2. 3 times 2 is 6. 4 times 3 is 12. The next term, like we said, is 5 times 4. We get 20. So a rule for this would just be n times n minus 1, the term before it. So this isn't, just a pattern that jumps out at you, but when you start to recognize something that's, you do notice, try thinking about how you can write that down as a rule. Now, what I want you guys to do for this problem, I want you to describe this pattern. You don't have to describe it down in words. I don't want you to type in your description. But what I do want you to do is write the next term and then write a rule. So you should have a rule. It should look like this, like f of n equals n minus 1 times n, something like this. Or, a to the sub n equals negative n cubed. So I want you to go ahead and write out your rule as well as give me the next term. So your answer should look like this, but you don't need to explain or describe the pattern. Okay, so these are the problems you're going to look at right now. 1, 3/2, 2, 5/2, so on, and then 0, 3, 8, 15. So give me the next term, so the fifth term in each one, and then what your pattern is. So for both A and B. So separate A and B in this next problem space, and then tell me those two pieces of information.